Good morning, guys. Very good morning to everyone. I see many good mornings in the chat. Okay, and my name is Shiva Charan. So I'll be doing training for you for the next 2 to 3 days. Okay, in the next 2 to 3 sessions, I'll be the one training you. Arvind is actually having some other work, so that is the reason I have taken up this. Yeah, good morning, everyone. Okay. So we'll just wait for another few minutes, okay? Let everyone join. We'll just wait for another few more minutes and we'll start the session, okay? Thank you. Okay, guys, I see this is the strength. We'll just wait for another 2 more minutes and we'll start the session, okay? Okay, just give me a confirmation if my voice is clear. And also, I see Rishabh, you have raised your hand. May I know your query? So, what exactly you are referring to, Mohit? What are you referring? What is the taxes that you are asking? Please be specific, okay? Okay, thank you. Thanks for the confirmation. Okay, Karthik, at the end of the session, I will be saying regarding that self-paged and also, yeah, Gaurav, I will be answering your query also. But at the end of the session, we will be answering all those queries, okay? So please note down your queries. And at the end of the session, that is in the last 10 minutes, we'll be resolving all those queries, okay? Not right now. Okay, fine. Okay. So I see that previously in the last 2 days, you're done with what are all the topics you're done with, guys? You're done with the prerequisites for GenAI, right? What exactly the GenAI, the tools required, and the Python basics and the library overviews. And then you're done with the sequential models, right? RNN, LSTM, correct. Sequence to sequence models, GRU. You're done with all these things. So in today's session, you will be getting to know what are embeddings, and the representations, okay, like word to vector, glow, sentence embeddings, cbow, okay, all these vector embeddings you'll be getting to know. But before getting to know about vector embeddings, we'll be getting to know about NLP, okay, NLP, natural language processing, okay. Is that clear? Today's agenda, everyone? Fine. Okay. So, anyone worked on any NLP concept before? Any NLP model? Anyone? Anyone have worked on NLP? Okay, I see few yes and few no. Let me just keep a poll. That will be better, right? Just give me a minute. So, just let me know. I have just created a poll. If you are aware of NLP, just let me know. Okay. If not, also just let me know. Okay. According to the majority, I will be moving along with the topic. Okay. Okay. Text summarization you have done. Okay. Good. Good, Shriday. Okay. Okay. I see around 260 plus people in the session. So everyone, please participate in the poll. NLP is very easy to understand. Okay. NLP is very easy to understand. So please let me know. Okay. You have used it for chatbot. Okay. I'll just wait for one more minute and I'll just proceed. Okay. I'm just waiting for the poll responses. I just see only 120 votes as of now. Okay, I see majority of you are aware of this NLP concepts. Around 100 plus people are aware of the NLP concepts. Only around 40 people were not aware. It's totally fine. You people are making my work a bit easier. Okay. So I'll just try to finish off all the NLP applications and also this whatever the types which you need to know, whatever the components which you need to know. I'll just try to finish it off in 1 hour. Okay. Fine. Okay. Bhavit. Thank you. Fine. Just give me a minute. So, as you people are aware of it, instead of going through the PPT, I'll just take the notepad and we'll do the things as per the notepad, okay? And how as per the notepad, I'll just show you, okay? Let me just open my notepad and share my screen. Let me know once you people are able to see the screen, okay? The notepad screen. Just give me a minute. Yeah, everyone able to see the screen, right? The notepad screen. Okay, Fine. So now we'll be discussing about this NLP. Okay, NLP. So what exactly is NLP? What is NLP, guys? NLP. So as of what we know is natural language processing is NLP, right? So what exactly the how the things happen in NLP and how the things process? What is the definition of NLP? See, as of what we know, we just know that it is a field of computer science, right? In the computer science field, we'll be getting this concept NLP, correct? So we can say one pointer. It's a field of computer science. Okay, so you can write right. It's a field of computer science. Correct. It's a field of computer science. So this is one kind of a definition we can give. It's a field of computer science. But what does NLP do exactly? It will help us to study, right? Or else it will help us to study how the computers will be understanding and processing the human language. Correct. So that is what exactly the NLP is. So NLP is nothing but it's a field of computer science where we study how the computers can understand the understand or else understand and process. We can say understand and process the human language. So in short, if anyone asks you like what NLP exactly is, you can say that it's a field of computer science where we study how these computers were able to understand and process the human language. Okay, understand and process the human language. I hope the definition is clear to everyone. So how it is able to understand the human language and generate the output in the format of a human language. So that is what the NLP is. NLP is nothing but again natural language processing. Okay, I see few responses also by Prabhat, Jitin Deep, and Anubhav. Okay, understand and generate the text and speech by combining computational linguistics. Okay, teaching computer to understand and process human language. Okay, NLP allows computer to process text, speech data, analyze its meaning. Correct. Okay, I see few responses. Fine. So in short, you can say this as a definition. Okay, along with your point. Okay, it is a field. I can say it is. It's a field of computer science where we study how the computers understand and process the human language. So this is what the NLP is. Okay, this is what exactly the NLP is. As you people are aware of it, can anyone say what are the main components of NLP or else NLP applications? Let's discuss about applications. First, let's discuss about application. I see few of you are aware, right? What are some of the NLP applications you can say? NLP applications, guys. Okay, text generation, Alexa, GPT. Okay, you're saying GPT. Fine. Text summarization, yeah, machine translation. We can say. Good one, Dishang. Machine translation in the sense what it is again? Translating from one text to another text, right? Translate from one text to another text. Correct. Machine translation. And what are some other applications? What are some other applications that we can consider? We can consider this chatbots, right? Chatbots, we can say. And also question answering chatbots, we can consider. Correct. Question answering chatbots. Yes. Handling customer support. How it handles the customer support? Sentiment analysis. I mean, the major backbone is sentiment analysis. From that, we are handling one of the customer support. Sentiment analysis. Sentiment analysis. So these are some of the NLP applications. Yeah, so web scraping, not exactly, but fine. Okay, fine. I got enough answers. Thank you. So what are some of the NLP applications? Machine translation. Machine translation means translating from one text to another text. Okay. Chatbots, you all know what exactly the chatbots are, correct? And the question answering chatbot, whatever the question is being asked, there will be an answer to that particular question. So the chatbot will be able to answer as per the query, right? So that is one of a question answering chatbots. Then comes the sentiment analysis. Everyone knows about the sentiment analysis, right? Sentiment analysis. Yes. Either it is a positive, negative, or it's a neutral sentiment analysis. Okay. It could be any one of the analysis, correct? So now these are the applications, fine. So before that, before discussing the components, anyone know the layers of NLP? Layers of NLP. Anyone aware of this? Those are the components they want. Layers. I'm talking about layers. Yeah, lexical analysis, correct? Semantic, correct? Semantic analysis, pragmatic analysis, morphology, speech, lexicon, phonology. Aware of it? Yes, got it. So what are the layers? How many layers are we having? 7 layers, right around? So what is the first layer we can consider? Consider semantic. Okay. Semantic analysis. Yeah, pragmatic, correct. So what is this semantic analysis? Semantic means the meaning, right? The context. The context of that particular paragraph which we're having. The context of the paragraph. Correct. Yeah, checks the meaning. So semantic analysis is nothing but the meaning, right? Meaning of the document. It's a para or the data, document or data, we can say. Document or data. Semantic analysis is meaning of the document or the data. Correct. So, can anyone give me an example of the semantic analysis? Example. Example. So, I'll just give an example. A bank is located on the bank of the river. So, now if I give this particular word or else if I give this particular line or a sentence and do the word embeddings by using the NLP methods, okay, by using the NLP method, I do the word embedding. And when I ask a query, it should be able to understand, it should be able to understand each and every word and its embedding and remember the meaning of this particular word, okay, and it will be giving us an output. See, how did I give a bank? This is an actual bank, okay, is located on the bank of the river. Bank of the river is different when compared with the bank, right? Getting the thing. Semantic analysis means meaning of the document, meaning of the documents or else meaning of the sentences or the data present in the document, okay? Meaning of the data present in the document. This is better. This is much better, okay? See, named entity recognition is different, Aditya. Let me just complete these layers and we'll move to the main components, okay? See, semantic analysis is nothing but understanding the meaning of the data or the sentence or the paragraphs which are present in our document, okay? So let's say this is the line present in our document. This is the line present in our document saying bank is located on the bank of a river. So normally if you do the vectorization, each and every word will be vectorized, right? But here it needs to understand the semantic meaning, or else the meaning of this particular sentence which is being embedded, correct? It needs to understand what a bank is and also bank of a river is. Okay, it needs to understand. So it will be understanding when you are asking a query, it will understand which bank are you referring to. If you are referring to river, if you just ask a query like where is river located, or else where exactly the bank is located. So if you want to know where exactly the bank is located, yeah, financial bank or a river bank. See, this is a river bank. Okay, this is the bank of a river is a river bank. This bank you can consider as an blood donation bank or else a financial bank. Okay, did you understand what exactly the semantic analysis means? Everyone, and also please confirm me. Is there any lag in my voice, or else is there any disturbance from my side? No. Okay. So Kushi, please check the internet connection from your side. Okay. Thank you. So everyone understood, right? Up to semantic analysis, what exactly semantic analysis means? Okay, fine. Thank you. So now the first layer is done. Semantic analysis. Okay. So then comes this. We can consider morphology, phonology. Let's consider phonology. Okay. Let's consider phonology. So what exactly is phonology? Phonology is it's a study of sound. Okay. Study of sound. Of sound known as the sound language also we can consider. Yeah, sound structure analysis we can say. Okay. Study of sound or else sound language we can say. Okay. Phonology made our work bit simple, right? Exactly, it was straight to the point. Fine. And what is the other things we can consider? There is this speech and lexicon also. Lexicon analysis is nothing but the vocabulary. Okay. Lexicon is nothing but it is related to vocabulary. Lexicon is related to vocabulary. So similarly, we are also having this morphology. Okay. Morphology. What exactly is morphology? What exactly is morphology, guys? Morphology is structure of words. Okay. Structure of words. What is the structure of words? Yeah, word structure analysis, we can say. Yeah, what is this exactly, Aditya? So, in a sentence, yeah, speech recognition, you can go for this lexicon, okay? Lexicon. Lexicon, or else you can go for, yeah, lexicon, you can go. I'm asking about morphology, okay? No, no, not lemmatization or stemming, okay? Not lemmatization or not stemming. You're wrong. I mean, you're not exactly to the point, okay? You're referring to the components. Here we're talking about the layers, okay? That is different, Jay Kumar. I'm asking about morphology. See, it is a structure of words. See, in a sentence, let's say there is a sentence, okay? Let's say there is a sentence. How can we say that that particular sentence is following the structure? Is following the structure. How can we say? See, there is this concept. Each and every sentence, we say that particular sentence is perfect when it is following this subject, verb, object. Okay. Yeah. Check how do you check the grammatical rules? When it is following the subject, verb, object concept. Okay. SVO, subject, verb, object. Okay. When it is following, when the particular sentence is having this structure, having this particular structure, subject, verb, object. Study of this is known as a morphology. Okay. Each and every sentence which we say is perfect will be having this particular format, subject, verb, object format. Okay. Clear about morphology? Okay. So after morphology, we are having another two, which is syntax and pragmatics. Okay. Okay. Phonological, morphological, lexical, syntax, contextual, cognitive, correct. There are many layers, but mostly we'll be discussing another two layers. Okay. What is the other layer? I just told syntax, right? So syntax means you all know grammar, correct? Grammar, related to grammar. What is the next last one, which I just told? Pragmatics, right? What is pragmatics? Pragmatics is different. Okay. Pragmatics, it is related to how the language is being used. Okay. How that particular language is being used in the particular context. Let me just write you. Okay. Language is being used in the particular context. Okay. So these are few layers of NLP. Okay. Semantic analysis, phonology, lexicon, morphology, syntax, and pragmatics. Okay. These are the layers of NLP. So until now, what did we discuss? We have discussed about NLP and what exactly is NLP. Right? Then followed by the applications we have discussed. What are the few applications, main applications that are present? And then we have moved forward with the layers of NLP, correct? And there were around 7 layers of NLP which are mainly used: semantic analysis, phonology, lexicon, morphology, syntax, pragmatics, speech related analysis, cognitive analysis. Okay. So these are layers of NLP. Okay. Okay. I see a few queries now. Yeah, context based on like grammar, vocabulary. Pragmatics focus on, yeah, structure and meaning. So yeah, how that particular language is being used in that particular context. So that is what the structure and meaning is. Anyone any doubts until now? Clear? Clear everyone? So before moving into NLP, okay, before moving into this NLP component, you need to know three things. You need to know three things. First one is what is corpus, what is corpora, okay, corpus, corpora, and there is another library. You need to know about that library. Okay. How many of you know what is corpus? Okay. Okay. I see if you, yeah, collection of documents we'll say. Okay. So corpora is nothing but a single document. Okay. A single document. a single document. Remember this, the difference between a corpus and corpora, which is important. Okay. So corpus is nothing but a collection of documents, is nothing but again a large data set, where we are having multiple files. Okay. So inside a folder, we'll be storing multiple text files, right? So that is what the corpus is. Okay. And if you're considering only one single text file, that is corpora. Okay. So this is the main difference between corpus and corpora. And one more thing you need to know about this library, that is regex. Regex library. Regex, or we can say RE library also we can say. This is very important. Okay. It's nothing but again regular expressions. How many of you know regular expressions? Why do we use regular expressions? To find the patterns. Okay. To find the patterns, and we can do the replacing. So mainly we use regular expressions library to pre-process the data. Okay. To pre-process the data, whatever the data which we are having, in a document, or else in the whole collection of the documents in the whole corpus or corpora. If you want to pre-process the data, we can go for regex library. What kind of pre-processing we can do? We can do the replace, we can remove the things. Okay, we can do the replace and we can remove the things. All those special characters removal, adding all the special characters if any, if we require. Okay, all those pre-processing things we can do through the regex library. So these are the main things you need to know before diving into NLP components. Okay, let me just keep this over here. Now we'll dive into NLP components. Okay, clear, right? Corpus, corpora, and regex. So now we'll discuss about this NLP components. What are the main components of NLP? What are the main components of NLP? Tokenization, right? What is tokenization, guys? What exactly is tokenization? It is nothing but breaking down the text into small units, right? Breaking down text into smaller units. Okay, smaller units. And we'll call that small units as tokens. Okay, we call the small units as token. Yeah, individual words, or else smaller units we'll say. Okay, individual words we can say. Breaking down the text into smaller units called as tokens. So I'll just give an example. Mostly people know. Okay, can anyone give me an example? Let's consider this. The session is from 10 to 12. Okay, so the session is from 10 to 12. So this is the sentence which I got as an input. Okay, this is the sentence which I got as an input. So now what I need to do, so this whole thing is the complete text. What is tokenization? Breaking down the complete text into smaller units called as tokens, right? Now I need to divide this complete text into tokens. So now what happens here? Now the tokens will be the session is from, sorry, 10 to 12. So how many tokens I'm having? How many tokens I'm having? How many tokens I'm having now? Okay. So I just got an answer saying 7. Let me just count 1, 2, 3, 4, 5, 6, 7. Okay, fine. Got it, got it. So how many tokens I'm having? 7 tokens I'm having. See how did I consider if I'm having a comma? Like, uh, let's say here I'm not good in grammar. So let's say I have kept a comma over here, okay, and I have given that as an input. So now what happens? Now what happens? How many tokens I will have? How many tokens I will have? I will have 8 tokens. Okay, I will have 8 tokens. Okay, so it will consider each and every character while doing the tokenization. Tokenization is nothing but considering each and every character which is involved in building that particular text and dividing them into smaller units, and we will be dividing them into called as tokens. Okay, Gaurav, or else I'm sorry, Garav. Okay, Garav, here we are having 8 tokens now. If you are having an at the rate in between, okay, from and after from, if you're having an at the rate, so it will be another extra token, so that will count up to 9 tokens, right? So from for now we are having 7 tokens. Okay, for now we are having 7 tokens. So everyone understood what exactly the tokenization is? Understood everyone tokenization? Okay, so after this tokenization, what could be the other main component? NLP not components, main components it should be. What should be the other component? No, stemming and limitation, not right now. Okay, we can go for stemming and limitation. Okay, fine. Let me just write that from the last few minutes I'm saying this. Stemming and limitization. Limitization. Yeah, correct, Shardul. Actually, we can go either way, okay? We can do either stemming and limitization, or we can directly go for stop word removal, okay? Fine. So I see everyone knows, right? So what is the difference between stemming and limitization? What is the difference between stemming and limitation? I don't want any answers from Google, okay? I just want answers from you. Okay. Okay, running run limitization. I see everyone knows this running word. Can I get any other word for limitization? No other. Uh, no, it's not correct. Other. Studies to study. Walking, walk, running, run. So, other what you're giving example like running is run, right? So that comes under stemming. Okay. Running is, so in stemming what happens? You all know prefix and suffix, right? So the suffix will be removed over here. Okay, now in the stemming, if you apply stemming on this running, we'll get this word. Okay, we'll get this word. And if we apply limitization on running, okay, if you apply the limitization on running, so it is giving me the this word. Did you see the difference? This is the difference between a base word and a root word. Okay, base and a root word. So in stemming, we'll just get the base word. Okay, stemming will get the base word, and in limitization, we'll get the root word. Okay, root word. So in stemming, this is the main difference. This is what the stemming is. Okay, what the stemming is, and this is what the lemma is. Okay, lemma. Okay, okay, fine. So there is this question from one of your friend. Actually, the question is very good. Okay, So how lemmatization and stemming helps us in NLP? Very good question. How lemmatization and stemming helps us in NLP? See, in NLP, we're having many words like boys running and jumping in the park along with his friends, we can say, or else in the park, like the boys running and jumping in the park, playing joyfully, or else let's say some words are there. Okay, so if we consider the same sentence and we embed this, it will be taking a lot of vector space. Okay, for this running and for jumping, instead of adding this running and jumping, we can directly do this stemming and limitation and convert them into a root word or else a base word, and then we can do that stemming or then we can do the word embedding. So if I apply stemming and limitation on this, a boy is run and jump in the park. Okay, in the park. So this is what it will be converted into when I apply stemming and limitization. Okay, stemming and limitization, this is what it happens. So what it is doing over here, it is bringing the words into its base form. Okay, its base or the root form. So then again, on these words also there is another main component. Okay, there is another main component, that is stop words. Okay, let me just write over here. So stop words, there were around 250 or 260 stop words we are currently having. Okay, around 250 or 260 stop words we're currently having. So now what happens here, the stop words will be removed. Okay, from this sentence, when I applied stemming or limitization, it has written into root word or the base word. Okay, let's say I have applied a limitization. I got the root words. So a boys run and jump in the park. So on this, the stop words will be applied. Okay, the stop words will be applied. What are the stop words? A will be a stop word. Is and in the. So these are the stop words. Okay, these are the stop words. And also we're having another stop words like they, them. Okay, these are the examples of stop words. Okay, examples of stop words. So let me just keep it over here. So this is the example we're considering. Example sentence. Example sentence, a boy is running and jumping in the park. And now immediately we'll convert them into tokens. Okay, we'll convert them into tokens. Yeah, punctuation marks also. Okay, we'll convert them into tokens. So first process is tokens. So how many tokens we're having? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, and also if we are including this full stop, then it will be 10. Okay, 10 tokens we'll consider 10 tokens. And if you apply limitization, what we'll get this sentence after limitization. A boy is run and jump in the park. And then if you apply stop words, what we'll get? If you apply stop words, we get boy, run, jump, park. Okay, this is what we get when we apply stop words. Okay, let's say after applying the stop words, and this one is after applying the limitization. This is the example sentence. And tokenization, you all know, right? Tokens, dividing the whole new text into smaller units, or breaking them into individual words. Correct. So up to stop words clear. So this is how things happens. And now what exactly happens after this? After this, if you want to convert them into embeddings, then you can convert them into the embeddings. So what embeddings you'll consider? Vector embeddings only. Okay, you'll consider the words into vectors. And to convert the word into vector, we are having word embeddings. Okay, we're having word embeddings. In the word embeddings, we're having both word to vector and CBOW, where the words will be converted into vectors. Okay, the words will be converted into vectors. So now there is this concept POS and also NER. Okay, NER. What is POS? Parts of speech. Okay, this is parts of speech, and NER is named entity recognition. Okay, named entity recognition. Everyone aware of this parts of speech and also NER? Yeah, correct. POS tagging. So POS tags will say POS tags, parts of speech tags. Okay. See what exactly this parts of speech tag is? See, if this is a sentence. Okay, if this is a sentence we are getting, a boy is running and jumping in the park. So it will consider each and every word. Okay, each and every word. Let's say we are given the same word, or else we are given this word. Okay, after performing the stop words and after performing the lemmatization, we have given this particular sentence as an input to this POS tags. So now what happens? It will identify all the parts of speech. How many types of parts of speech we are having? 8 or 7? How many are we having, guys? 8. Okay, fine. 7, 8. Still a confusion, right? Fine. So it's noun, pronoun, verb, adverb, adjective, conjunction, interjunction, all these things. So now, if we apply this POS on a sentence, it will identify which word is a noun, which word is a pronoun, which word is a verb, and which word is adverb. Okay, all the adjectives, yeah, prepositions, conjunction, interjunctions, correct. It will assign all the tags to each and every word. Okay, POS tags means identifying the parts of speech for each and every word. Okay, tag is nothing but tagging each and every word. A tag is assigned for of POS. Okay, so that is what the POS tags are. So then coming into name entity recognition. What is this name entity recognition? So name entity recognition is nothing but it will help us to identify the popular or else well-known people name. Okay, or else the places, or the or else we can say organization names. Okay, organization names. It's like, yeah, someone just updated it. Identify the entity, correct? So it will just help us to identify entity. What kind of entity? Either it could be people, it could be place, it could be organization, anything. Okay. So I see many of you are giving examples also. I just want one good example. Example of this NER. I can consider this example. Let me just come up with an example. So let me just say this. Tim Cook. Tim Cook is having an Google Pixel, correct? I can consider this example, right? So now what happens to Tim Cook? Tim Cook will be recognized as Cook will be recognized as name, correct? So it will be noun, right? So what is this Google Pixel? Google Pixel is, again, we all know that Google Pixel is a phone, right? These two will be recognized as nouns, and there is this is having an as per the parts of speech, it will be recognized. Okay, so the tags will be assigned to this. Clear? Clear, guys? Until now, is it clear? The whole NLP? Everyone? Okay. Now, okay. Fine, fine. Just a minute. Integration, regex. Yeah, fine. Okay. So now, can anyone give me an example sentence? I'll just walk you through the workflow. Okay. Example sentence. So in this workflow of NLP, can anyone give me an example? A random sentence, or else a random line. So Aditya, fine. I got this. It's too big actually. So let me just cut it down. It's fine, right? Everyone? Okay, fine. So initially we are having a sentence. Okay. So let's say I'm having a huge corpus. Okay. It's a collection of documents I'm having. So what I will be do initially, I will make sure that I'm having all the documents under one single document. So I'll create a one single corpora. Okay. I'll create a one single corpora, that is one single document, and I will have all the content which is included in all other documents in one single document. Okay. Let's say in that one single corpora, this is the sentence, okay, which is present. Now, what initially I will be doing is I will convert. So major workflow of this NLP, what everyone will be doing is they'll make sure that they'll create a function to do the pre-processing. Okay, pre-processing. Pre-process is very important in NLP. Okay, so in order to do the pre-process, what exactly we'll be doing is first initially, let's say we have assigned a variable a. Okay, variable a, and the value is this sentence. Okay, this whole sentence. So now what exactly happens in pre-processing is first initially we'll convert all these uppercase letters to completely lowercase letters. So we'll just apply this lower method. Okay, to apply this lower. So what exactly we're doing? Converting all the letters or else all the words to lowercase. Okay, convert all to lower. Convert all to lowercase. Okay, this is the first step. This is the first step in the pre-processing. We'll convert everything into the lowercase letters. Okay, we'll convert everything into lowercase letters. And after converting everything into lowercase letters, what we can do? We'll apply the regular expressions. Okay, now here comes the regular expressions. And what exactly we'll do in the regular expressions? We will remove the special characters. Okay, if we are working on only words and we don't want the special characters, then we'll remove the special characters. What kind of special characters? In if you do a web scraping, we'll get most of the hashtags, right? If you do a web scraping on any Twitter movie review, we'll get most of the hashtags, or else we can get the at the rate characters, and also we can get asterisks, right? Asterisks. We may also get and in between. Right? We may also get this even this symbol. Where is that? Yeah, even this symbol also will be getting in between. If you have done web scraping, Yeah, this symbol, or else we can get the dollar symbol. See, most of the time we'll be getting all these special characters, right? So to remove all these special characters, we can use the regex. And let's say if there is a pattern followed, if there is this special character found in this particular sentence, in this particular sentence, a special character is found. If you want to remove, we can remove, or if you want to replace that, we can replace it. Okay, mostly we'll be replacing with empty. Okay, then after applying the regex, what we'll be doing is, then now comes the main components. Then we'll convert them into tokens. Then after tokenization, we can either go for stop words or else stemming. Okay, let's go for stop words first. Stop words, then we can apply stemming or lemma. And when to apply stemming and when to apply lemma? Mostly we'll apply stemming when we're having a huge corpus. Okay, huge corpora. Okay, and lemmatization when we're having a less amount of data, we'll go for lemmatization. Okay, stemming or lemmatization. Then comes the POR stacks if required, NAR if required. Then we'll go for the actual word embeddings. Okay, then we'll go for actual word embeddings. Until here, everyone should follow the same process. Okay, until here, for each and every NLP document, we need to follow the same process. From here, everything will be different. We can close up to here also, or else if you want to move further, we can do the word embeddings. Understood until now? Clear everyone, the workflow? So I see three hand raises, Tushar, Pratham, and Kirti. So if you're having any query, let me know. If anyone is having any doubt, do let me know. I'll just give 2 minutes of time. Pre-processing. You want me to repeat the pre-processing? Fine. So let's say I'm having a corpus. Corpus is it's a collection of documents. Okay. Corpus is collection of documents. So it's nothing but just imagine you're having a folder on your desktop. Okay. You're having a folder, and inside that folder you're having multiple files or else multiple folders. And inside the multiple folders again, you may have the multiple files, right? Okay. A folder having a multiple files. It's like a corpus, a collection of documents. And corpora is nothing but one single document. Okay. Corpora is nothing but one single document. So now for this variable which I have assigned, this is a sentence. Okay. What is this sentence? If I'm having multiple files in multiple folders, what I will do initially, I will just consider everything under one single file. Okay. Everything under one single file I'll consider. And that file name, let's say that file name is like new dot uh, new.csv or txt. Okay, let's say txt. Okay, in this text file, whatever the multiple text files I'm having, I have combined all of them into one single text file called new text. Okay, new text file. On that new text file, what happens now? in this new text file, let's say I'm having this sentence, okay? Let's say I'm having this sentence in this new text file. So then I need to go through the pre-processing steps. What are the pre-processing steps? Initially, I will create a function, okay? I'll create a function and involve these steps, okay? And involve these two steps in that function because I want each and every line to go through that process, right? Each and every word, or else each and the whole file needs to go through that process, right? So initially I will convert them into all the lowercase letters. Then I will remove the special characters. And if there is any extra space in between para to paragraph, if I want to remove that also, I will be removing that. Then I'll go for the tokens. I will do the tokenization process. After doing the tokenization, I can go for stemming or else I can go for stop words. Anything is fine, okay? So initially here I went for stop words. Okay. After going for stop words, what happens in the stop words? All these kind of characters will be removed right in the stop words. A, is, and, in, they, them. These kind of words will be removed in the stop words, okay? Now what exactly happens? Then the stemming or lemmatization occurs. What is stemming and lemmatization? This is stemming and this is lemmatization. This is stemming and lemmatization. Stemming means the base word, lemma is the root word, okay? We'll just do that. And after doing that, what we'll be doing? We will either go for this POS tags if that is included in our task. If not, we'll go for NER if that is included in our task. If not, we'll directly go for word embeddings, okay? So up to here is the main pre-processing steps which we follow. Okay? If you are working on any sentiment analysis project, these are the main pre-processing steps which we follow. Okay, these are the main pre-processing steps which we follow. Clear? Okay. Okay, let me just come to regex also. Okay? Regex, regular expressions. Where did I write? Yeah, regular expressions. Okay, fine. So, what did I write here? All the special characters, right? See, let's say I'm having a document. Okay, document. Let's say I have web scraped a particular website. Okay, I web scraped a particular website. In between, I'll be getting all these hashtags, at the rates, at the rate in the sense at the rate of gmail.com. In the sentence, you'll be having all these characters, right? Hashtag followed by, let's say, let's consider some people will be, let's say I have web scraped a Twitter data where that is related to a movie review. Let's say Sikandar, okay? Sikandar, okay, yeah, Sikandar or something, okay? Sin, let's say Sin, asterisk, and followed by some other text, okay? Some other text. So these are some kind of irrelevant words, okay? These are some of the irrelevant words which are present along with the special characters. Sometimes we'll directly find a huge space in between, okay? Huge space in between we'll find. So to remove these kind of things, okay? To remove these kind of things or else irrelevant characters or irrelevant words which are present in our particular Word document, because we don't want these things to be converted into tokens and then do the stemming and lemmatization, right? So in order to make sure we are removing all these special things or special characters or irrelevant words, we will use the regex. Okay, we'll use the regex. Once go through this regex library. Okay, I will share the link also. Once go through the regex library, I'll share the link. Okay, so to remove all these things, we'll be using the regex library. So let's say to remove this particular words. Okay, I'll just mention this is the character it needs to find in the sentence, and followed by whatever the word which we are getting, just replace it with this one, empty space. Okay, just replace it with empty space. We can either replace it or else we can directly remove it. Okay, and for this at the rate gmail.com, at the rate gmail, we can directly replace it with the empty space, or else we can directly replace it with email. I'll just mention what it needs to be replaced it with, or else I can directly mention empty space. So for each and every special character which is present in the sentence, we will not consider each and every special character and the irrelevant words. We'll just make sure that we are not considering them, we are dropping them. Why we are dropping them? To make sure our document is simple and clean. Okay, to make sure our document is simple and clean, and it is better for moving further. Okay, okay? This is what a regex is mainly used for, to clean the document. Okay, let me just write here too. To clean the document, regex is mainly used for to clean the document, and these are some of the examples over here. What kind of things we'll get? These are some of the examples. Okay, then we do the tokenization. After tokenization, you all know what is tokenization. Then we go for the stoppers. Then we go for stemming and lemma. Then we go for PO stacks. Clear? Is it clear now? Anshika, Swati, and it's not Swati, it's Swasti. I'm sorry. Is it clear, guys? Any other doubt? Anyone, any other doubt? Let me know now itself, because we won't be touching this NLP again. We'll be dealing with word embeddings, and then we'll go for transformers architecture. Okay, and then followed by the text to text implementation. So it will be completely GenAI related thing. We won't be touching NLP once again. Okay, so just make sure you are being clear. Everyone clear? Any doubts? Anyone? Let me just keep a poll, okay, through so that even I can understand. So please let me know. I have created a small poll. Let me know. And in the meantime, please go through the concept which I have discussed, which we have discussed until now. And I will also share this regex library also. Regex library, regular expressions. Yeah. In the W3 schools, it's very good. Let me just share this link. And everyone, please just go through this, okay? Please go through this. Okay, fine. We'll just have a short break, okay? Big concept we use everywhere, okay? If you want to do a sentiment analysis, we can directly go through all those workflow, and we can divide the data into training and testing, and then we can build a model where it will predict the input as a positive, negative, or a neutral in the sentiment analysis. That is what the NLP applications we have discussed, right? See, in the starting itself, where we can use NLP, some of the applications are present, right? Initially, we have discussed about these applications also. Sentiment analysis is one main thing. Chatbots, machine translation, translating from one language to another language. How it will be happening? By understanding the meaning only. Clear? See, if you are still having any doubt, let me know, okay? Let me know. Fine. What is this, Vishal? Vishal Kumar. Please don't spam, okay? If you want to say something, be clear. Okay, let's just have a break for 10 minutes, guys. I hope everyone is back. So Vishal, I have gone through your message. I see that you're working on a project and asking for some suggestion, right? Vishal Kumar. Okay, fine. Vishal is not responding. That's okay. No one. It's 2 hour session. Okay, fine. Yeah, correct. Okay. So NLP concept is clear, right? Everyone, Anshika, and also what was the other name? Yeah, yes, Swasti and also Anshika clear. Yeah, thank you. So now there is this small implementation. Okay, there is a small implementation which you need to do. I'll just share my screen. We'll understand the implementation and we'll end the session for today. Okay, let me just share my screen. Just a minute. I'll just walk you through that NLP PPT first. So natural language processing, you all have seen this. So it's nothing but the agenda. We have learned about this definition and scope of NLP, historic evolution. Evolution, I'll be saying after the embeddings. Okay, evolution, I'll be saying after the embeddings when we are about to discuss the transformers. Okay, so we have discussed about this importance across the industries, like the different applications, and also yeah, we have seen these applications also. Ethical considerations. Ethical consideration again, you'll see at the time of transformers. Okay, evaluating, retraining the model with different. See, these are different. Okay, these are different, which are not involved in this Gen AI concept. So what NLP is exactly? It's a combination of machine learning and deep learning, where in the whole AI bubble we'll have a machine learning, and inside the machine learning we are having deep learning, and with the combination of deep learning, machine learning, and AI, we got this NLP. It's like focusing on the computer's human language. What is the main goal of NLP? Enabling the machines to understand, interpret, and generate. This is important again. Enable the machines to understand, interpret, and generate the human language. This is important, okay? Understand, interpret, and generate. Scope of NLP. Just a minute. Okay. Okay. The scope of NLP. What is the scope of NLP? Text understanding. What is NLP? Is again the same. The goal. So these are the main things. Okay, these are the main things which you need to be aware of in NLP, and all the pre-processing, tokenization, all those steps we have already discussed. Correct. We have already discussed. Now I'll just share another PPT where you will be understanding the hierarchical workflow. Okay, hierarchy workflow you'll be understanding. Let me just share that once. Also, I have not received access for labs. How to access labs? For completing the video lecture and quiz, this showing GitHub link. No way to practice. What are you referring to this, Kirti? I'm not exactly not sure. Video lectures. You mean the recordings you're saying? Everyone, you're talking about the recordings? Okay, the courses and skill wallet you're talking. I will discuss about that. We'll discuss about that. Okay. Let me just complete this. Let me just complete this. And there were few cells which we need to run regarding the embeddings. Or else we'll just complete this topic for today. And tomorrow we'll do the implementation of that embeddings. That is in our next session. Then followed by we'll discuss the transformers architecture. Okay. Let me just share the screen first. Okay, this particular PPT is related to vector database, but you'll be understanding the workflow. So that is the reason I have displayed this slide. Okay. So in the NLP for text representations, we're having word embeddings. Okay. And for that word embeddings, we're having two different types: word to vector representation and the globe. Okay. Globe. What is this globe again? Globe is nothing but the global vectors. Okay. Globe is nothing but the global vectors. In the word to vec, we are having SIBO, skipgram, and here we are having transformers type, contextual embeddings. And coming into contextual embeddings, we are having semantic. Under the semantic, we are having vector similarity search. Under that, we got the database. That is how the vector database got into the picture. But we'll not see these. Okay, we'll not see this. We'll just discuss about this SIBO and skipgram. Okay, SIBO, skipgram. Fine. What to make? So initially, what exactly are word embeddings? What exactly are word embeddings? Word embeddings is nothing but each and every word which we are having that will be embedded into vectors. Okay, what kind of vectors? Dense vector. Okay, dense vector representation. Representing a word into a vector format is known as a word embedding. Okay? Representing a word in a vector format is known as word embedding. What is the definition here? What it is saying? Word embeddings are dense vector representation of words where each word is mapped to a point in a continuous vector. Correct. See this line. Each word is mapped to a point in a continuous vector space such that the semantic relationships between words are preserved. Semantic meaning, remember the semantic meaning, the actual meaning of that particular sentence or the word. So, how the semantic relations are how the semantic relationships are being preserved by mapping each and every word to a dense vector. Okay, by mapping each and every word to a dense vector, we are preserving the semantic relationships, and that process is known as word embeddings. What are the key characteristics of word embeddings? It will convert the words to numerical vectors. Okay, one point is it will convert the words into the numerical vectors. Fine. And what it does by converting them, it will capture the meaning and context and the relationships. Okay, it will capture the meaning, the context, and the relationships of that particular words. Okay. And what is this words with similar meanings have close vectors? It is nothing but again the similarity search. Anyone aware of cosine similarity? Cosine similarity concept. These close vectors mostly you'll be dealing when you're dealing with cosine similarity. So these are some of the key characteristics. Anyone aware? Skill boost. Fine, fine. Skill boost is fine. Okay. Okay. Thank you, Varma. Also, can you share the NLP notes in the WhatsApp group? Satyam, are you referring to the notepad notes you're saying? Do you guys really need the notepad notes? Okay. And I'm sorry we can't share the PPT. Okay. And coming into your group, I see there is a Telegram group, right? I'll just share that particular notebook with Arvind. He'll be sharing that notes. Okay. Not having the Telegram group link and also your WhatsApp group link. Okay. So Arvind will be sharing the file with you. I'll share the file with Arvind. Okay. So now this is about word embeddings. Word embeddings is nothing but just remember dense vector representation. Okay. What it will capture? It will capture the semantic relationships. Okay. It will capture the semantic relationships. So in the word embeddings, we are having two. Word-to-vec, SIBO. Okay. Word-to-vec and this word-to-vec only we are having. Under the word-to-vec, we are having SIBO and skipgram. Okay. What is this word-to-vec? Word-to-vec is nothing but word to vector. Okay. Word to vector. It is actually developed by Google. Okay. This word to vector is developed by Google, and uh, it learns the relationships. Okay. It learns the relationships from word to word. Okay. For the large text data we are having from that large textual data, it will be learning the relationships for the words in this word to vec. It is developed by Google. And under this word to vec, we are having CBOW and skipgram. What is CBOW and skipgram? CBOW is nothing but continuous bag of words. Okay. CBOW is continuous bag of words. And skipgram. What is skipgram? Skipgram is nothing but what exactly it will do is it will predict the surrounding words. Okay. It will predict the surrounding words. Clear? I'll just show you the particular slide also. So Vertex is a popular word embedding model. Okay, popular embedding model. And what it is saying, it is introduced by Google in 2013, and it will mostly say about how the words are represented numerically. And then there were two architectures, that is continuous bag of vectors and skipgram. Each has its own importance, or else each has its own training approach. Okay. And what is the data which is used for this? CBOW and skipgram, vast text corpora, that is Google News. Okay, Google News. So now skipgram and CBOW. What is CBOW and skipgram? Just see here. See the difference. In the CBOW, the training speed is fast, better for frequent words, and predicts the target word from the context. So we'll be providing all the inputs and it will just predict the target word in the SIBO. In the skipgram, what happens? The training process is a bit slow and it is better for rare words, okay? And it will predict the context from the target word. Let's say the target word is a single word, and based on that single word, it will generate the whole sentence, okay? It will generate the whole sentence. And in the SIBO, by giving the whole sentence, it will predict the target word, okay? It will predict the target word. So this is the main difference between a SIBO and the skipgram, okay? SIBO and skipgram, this is the main difference. Okay, this is about vector databases again. Fine. So under word embeddings, we are having word to vec. For word to vec, we got SIBO and skipgram. SIBO is continuous bag of words, faster training speed, better for frequent words. It will predict the target word from the context. Okay, that is SIBO. And skipgram, it is slower training speed, and it is better for rare words, and it will predict the context from the target words. Okay, target words. Just remember the difference between the SIBO and the skipgram. Okay. So this is about the SIBO and the skipgram. We are also having this globe, right? Globe is nothing but global vectors. Okay, I'll just walk you through globe. Okay, globe is nothing but the global vectors. It is developed by Stanford. Okay, it is developed by Stanford. What exactly globe does is it uses the matrix factorization. Okay, matrix factorization process it will be using over the current and the co-occurring word. Okay, co-occurring matrix. Also here after globe we also have a fast text. Okay, fast text is very important. Fast text, let me just write it over here in the chat. Fast text, this is a library from Facebook. Okay, this is a fast text is a library from Facebook which is very popular in doing the NLP. Okay, for NLP this is very popular, and for sentiment analysis mostly everyone will be using for this fast text only. Okay, it is very good for rare words. Okay, it is very good for rare words. So for now, knowing these concepts is fine. Okay, and we'll do the notebook implementation in the upcoming session along with the transformers architecture. Okay, is that clear, everyone? So this is it for today, guys. If anyone is having any doubts, you may ask me now. And also, Vishal Kumar, if you are in the session, you may ask your query now. Okay, I see that you have asked a very big query. I have just created a small poll regarding today's session. Let me know. It's a simple yes or no. Okay. So everyone, please ask your queries. Yes, there is an option for recording classes. You'll be finding it in the Skill Wallet portal. Okay. Skill Wallet portal, you'll be finding the recording session links. Okay. Recording sessions. Please complete that, Ronit. They will be informing you what are all the self-paced learning courses you need to do. Please complete that first. Okay? Any other queries, anyone? That is what I just told Mohit. The recording sessions you'll be finding it in the Skill Wallet portal, and I see someone updated that from path. Okay, from path it is accessible. It seems so. Please just go through that. Okay. Access to course. Which course you're not having access, Saurabh? See, Mohit, I have answered it already. Okay. In the skill wallet only, you'll be finding those recordings. Okay. You need to just register in that particular introduction to Gen. Okay. Introduction to Gen. Those in the related to skill boost. If you're saying you just need to register in that, you'll be having the access to labs. Okay. And Manya, you're saying that in the skill wallet portal, I didn't join earlier, so it is showing me to choose the cohort two. I'll just inform this to the operations team. Okay. I'll just inform them regarding this query. Okay. Just a moment. Okay, you're not able to access the lab. Okay, fine, I got it. So regarding the lab which you're doing on Skill Boost, okay, through the GCP, you need to mail the support Google support team. Okay, you need to mail the Google support team regarding those access. Okay, because sometimes it's the issue which is coming from the Google only. You can't do anything. We need to email the Google team. Okay, in that case, if you're unable to access the lab, I see an image uploaded by someone. So within your organization only, the access is restricted. Okay, try to do login through some other Gmail. Okay, in that case, Dhananjay. It has already been shared in your Telegram group. It seems, Saurabh. Please go through the Telegram group. Okay. Yeah, Arshdeep, if you're not having any query, you may leave. Thanks for attending. Mohit, I'll just inform Arvind to update those steps. Okay. I'll inform Arvind to update all the steps related to this lab access. Okay. He'll be updating, or else tomorrow Frankie will be taking care of all these queries. Okay. So no other queries related to this session. I see one no regarding today's session. It's totally fine. If you want to ask the query, you may ask, or else if this is it, you may leave the session, guys. Please ask. I have registered. the Google Cloud skill boost and also fill the Google form sheet to us in the previous session, but still when I'm accessing the labs there, it's showing us to buy the credits and make the account zero credits are showing. Okay, so the labs are asking for the credits and you're not having the credits. Okay, so don't start those kind of labs now. Okay, though for now, don't start the labs right away if it is asking for credits. So credits will be assigned to you. For that, a special the link will be shared to you to access the credits. Okay, for now, don't start the lab if it is asking for credits. Okay, I'll just inform the team if there are any credits available. Then we'll share. Okay, and coming into recordings. No recordings. I see someone updated in the Telegram group. You have received the recording links. Okay, Kunsh, we'll discuss about that. Okay, regarding the labs, just go through the left side pane steps. Okay, in the left side pane, you'll be having each and every steps, right? You'll be able to do that. Yeah, or else you can just reset that notebook as informed by the. Okay, I'm just showing in Telegram group. Okay, even I am not in your Telegram group, right? So I'm not able to get exactly what you're saying till when they will update that. Okay, Aditya, I'll just inform the team regarding this. Okay, just inform them. Fine. Kunsh, what was your issue? So in that case, see if the issue is related to everyone, if the issue is related to Google Cloud, Skill Boost, or else GCP, Vertex AI, all these things. I mean the Skill Boost related. Then you need to contact the Google support team in that case. Okay? And if there is a issue from our side, I mean if it is related to recordings or else if it is related to attendance, then you can contact us through team SIP at the Smart Bridge. Okay? Okay, this is a mail you need to contact. Okay, issue related to Skill Boost, contact the Google team, or else issues related to attendance, recordings, do mail to this email ID. Okay, fine. I will just end the session now. Thank you everyone. Thanks for joining. Thank you. Okay, see this. Yeah, thank you. I'm ending the session now.